The most amazing technologies ever developed by humanity, the Voyager spacecraft is just one of these remarkable innovations. Even after decades of constant discovery, they continue to awe us. Voyager 1 has just detected a massive object hurling through space despite the fact that the two spacecraft are currently carrying out separate missions. What was startlingly tracked down, bridging space close to the Explorer space apparatus? How will this affect Voyager's future space exploration? And why are scientists scrambling to find answers to this new discovery? We should figure it out. On September 5, 1977, NASA launched Voyager 1 as part of the Voyager program with the intention of studying the interstellar space beyond the Sun's heliosphere and the outer solar system. Explorer 1 sent off 16 days after its twin, Explorer 2, and entered interstellar space as the main counterfeit item to do as such. NASA's mission is to investigate the deepest levels of our solar system and the outermost reaches of space. Explorer 1 has been traveling for over 45 years and is presently the article made by people that is the farthest separation from the planet, estimated to be 14 billion miles away. Despite this, the Voyager 1 spacecraft's light takes only 22 hours, 2 minutes and 54 seconds to reach Earth, allowing us to continue acquiring new data from the spacecraft despite its vast distance. Explorer 1 was sent off after Explorer 2 due to a faster way. On December 15, 1977, it left the asteroid belt before its twin. It began its Jovian imaging mission in April 1978, when it was approximately 165 million miles, 265 million kilometers, away from the planet. In comparison to the Pioneer flybys of previous years, the images returned showed Jupiter's turbulent atmosphere. On January 30, 1979, Voyager 1 began taking pictures, which it did every 96 seconds for 100 hours. A color time-lapse video depicting Jupiter's 10 revolutions was produced as a result. The shuttle entered the Jovian moon framework on February 10, 1979, and toward the beginning of spring, it found a restricted ring around Jupiter that had never been seen. This revelation alone was a significant achievement for the NASA group back on the planet. Then, on March 5, 1979, Explorer 1 made its nearest approach to Jupiter at around 174,000 miles, 280,000 kilometers. It passed by several of Jupiter's moons, including Amalthea, Io, Europa, Ganymede, and Callisto, in a specific order, sending back staggering pictures of their scenes and uncovering completely new worlds to planetary researchers. One of the most intriguing discoveries was the planet Io, which was photographed with a strange yellow, orange, and brown glow, with at least 8 active volcanoes spewing material into space, making it one of the solar system's most geologically active planets. The possibility that sulfur dioxide-rich volcanic plumes from Io were responsible for the oxygen and sulfur in Jovian space was raised by the presence of active volcanoes. 3 additional moons were tracked down by the shuttle. Explorer 1 made its first course change after its encounter with Jupiter on April 9, 1979, to prepare for its meeting with Saturn. On October 10, 1979, a subsequent change ensured the shuttle wouldn't slam into Saturn's moon Titan. It flew by Saturn in November 1979, which was just as stunning as the first time. Voyager 1 discovered 5 new moons, a ring system with thousands of bands and spokes, wedge-shaped transient clouds of minute particles, and the shepherd satellites on either side of the F ring, which maintain the ring's sharp edges. A brand new ring known as the G ring was also observed. During its approach to Saturn, the spacecraft took pictures of Titan, Mimas, Enceladus, Tethys, Dione, and Rhea. The new information suggested that the majority of the moons were made of water ice. Titan was the objective that Explorer 1 passed by on November 12, 1979, at around 2,500 miles, 4,000 kilometers. Images showed a thick atmosphere that completely obscured the surface. The probe found that about 90% of the moon's atmosphere was nitrogen. At the surface, there were 1.6 atmospheres of pressure and a temperature of -290 degrees Fahrenheit -180 degrees Celsius. Titan may be the first planet in the solar system, other than Earth, with liquid on its surface according to data from its atmosphere. The discovery of more complex hydrocarbons, including nitrogen and methane, raises the possibility of Titan's primordial chemical processes. At 2346 on November 12, 1980, Explorer 1 made its closest approach to Saturn at around 782,000 to 900,000 miles. After the close encounter with Saturn, the rocket continued its central mission, sending back important information and pictures that continue to expand our understanding of the outer solar system and beyond. Explorer 1 set out to leave the nearby planetary group at 3.52 million kilometers per year, 35 degrees north of the ecliptic plane, generally following the Sun's movement. As for neighboring stars, the shuttle was not directed towards Uranus and Neptune due to the special requirement for the flyby of Titan. The main representation of the planetary group as seen from outside was made on February 14, 1990, when Explorer 1's cameras were arranged in reverse and took approximately 60 photos of the Sun and planets. The photographs were captured from a distance of 4.37 billion miles, 7 billion kilometers, from the Sun. A mosaic of those images resulted in the well-known image known as the pale blue dot, which was created by Cornell University professor and Voyager scientific team member Carl Sagan. The image has additionally been referred to as the family portrait of the solar system. Regardless of the shortfall of Mercury and Mars, only Mars' clouded side was visible to the camera since Mercury and Mars were on the same side of the Sun and remained invisible. To conserve power and memory for the intergalactic journey, the two Voyager spacecraft turned off their cameras after taking 67,000 photos. The Voyager 1 and 2 missions were included in the Voyager Interstellar mission, which was launched on January 1, 1990, following the conclusion of the last encounter with a planet in 1989. The new mission aims to extend NASA's study of the solar system beyond the region surrounding the outer planets and into the Sun's outermost regions. Information collection on the boundary between the heliosphere, the area of space overwhelmed by the Sun's magnetic field and solar wind, and the interstellar medium is one of the mission's specific goals. On February 17, 1998, Voyager 1 became the most distant object created by humans when it passed Pioneer 10 at a distance of 6.69 billion miles from the Sun. Voyager 1 scientists reported on December 16, 2004, that it had recorded high magnetic field intensity readings at 94.4 astronomical units, indicating that it had experienced the termination shock and was now in the heliosheath. The spacecraft finally left the heliosphere on August 25, 2012, becoming the first spacecraft to measure the interstellar environment. NASA claims that Voyager 1 detected significant environmental changes in June 2012, including an increase in charged particles and cosmic rays. Subsequently, Explorer 1 became the first spacecraft to enter interstellar space, a good distance of 121 cosmic units from the Sun. The heliosphere's inner boundary was indicated by this. It was fortunate that Explorer 1 didn't depend on solar energy at this stage, as sunlight required over 16 hours to reach it. Traveling more than 10 miles per second, Voyager 1 is separated from the Sun. At its current speed, Voyager 1 will take more than 73,000 years to reach Proxima Centauri, the star closest to the Sun, at a distance of 4.2 light-years. However, Voyager 1 is not traveling in the direction of Proxima Centauri but rather in a different direction, following the constellation in a straight line. As indicated by a NASA study, Mission Control detailed that Explorer 1 detected critical collisions with high-energy particles, which were once thought to be vast beams from supernova explosions far beyond the planetary system. Along with this increase in high-energy particles, there was a sharp decrease in low-energy particles from the Sun. According to Johns Hopkins University researchers, these two events were sufficient to demonstrate that Voyager 1 had left the heliosphere completely and was now in interstellar space. However, scientists soon discovered something out of the ordinary in the data. Dr. Ed Stone, the mission scientist for the Explorer shuttle at the California Institute of Technology, said in a statement that Voyager had found a new region of the heliosphere that we had not understood was there. Although the magnetic field is now connected to the outside, it appears that we are still inside. This makes it look like a highway that lets particles in and out. The area was 10 times stronger than experts had anticipated according to the strange magnetic field phenomenon. Before Voyager 1 left the solar system and entered interstellar space, it was anticipated to be the final obstacle to overcome. Since no spacecraft has ever left the heliosphere in the history of human space exploration, researchers have eagerly awaited Voyager 1's feedback ever since it entered interstellar space in 2012. They were surprised when, during one observation in the data they had just received from Voyager 1, they noticed a large object near the spacecraft. The spacecraft's cameras were already off, so they could not see the object Voyager 1 found. Nonetheless, it was detected in the information gathered by the shuttle instruments, which were still functioning properly. NASA specialists were initially stunned because they had never expected to detect such a large object in the interstellar medium, in contrast to anything Voyager 1 had previously observed. The massive object, which appeared to be a massive cosmic body, was moving at an incredibly rapid speed. The object's speed and direction demonstrated it was likely on a crash course with something in the interstellar medium. Scientists have had a lot of questions and concerns since this massive object was found. The spacecraft's mission and its ability to continue sending valuable data back to Earth could be seriously impacted if the object collided with Voyager 1. The object might actually harm or obliterate the space apparatus, which has been a crucial instrument for investigating the most distant ranges of our solar system and beyond. However, the specific nature and structure of the object remain unclear, and researchers are scrambling to examine the data and figure out what it might be. Some experts believe the object could be a rogue planet or an asteroid traveling through interstellar space, or it could be a massive comet or even a celestial body that no one has ever seen before. The scientific community is working to unravel the mystery of this unexpected find, which has sparked intense interest and debate. Scientists are keeping a close eye on Voyager 1's progress and the potential threat posed by the newly discovered object as it continues its journey through the vast and unexplored interstellar space. Explorer 1's mission, which was initially expected to endure a couple of years, has far surpassed all expectations and continues to provide important information about the outer reaches of our solar system and beyond. The spacecraft's capacity to detect and relay data about this mysterious object is a testament to the strength and reliability of the technology developed by NASA decades ago. One thing is certain, Voyager 1's journey into the unknown will continue to captivate and inspire us all as scientists investigate its implications.